Hello everybody, this is a Python playlist. You will not be seeing just day one or day two, but rather like we will be learning in bulk and try to get like squeeze max out of it. So we have this repository right here by Asabini. Thank you so much for your repository, for your input on learning all these materials. Thank you for contributing. So we will be using this, and I will, you know, uh, leave a link for this repository so that you can use that as well. And we'll also be learning through book. I will show you the book, but this will be on the background, right? If I do find some concepts that is that might catch my interest somehow in the book, I will share that as well. So here's the book I was talking about, Python Crash Course, second edition. So yeah, I'll be reading this book, and not obviously on the recording, but on my own, and I would definitely recommend you to check out this book as well to at least get into the intermediate level in Python, so that like that's just a gate for us to literally just dive in all the way into REST APIs and AI and ML and everything, right? So yeah, these are materials for now, and after that, I will once we are fully done with Python, once we do some projects, we do some brainstorms, I will go into the free code um, website and we'll take some tests based on that. Okay, so that's the plan for Python, and let's get it going. Let's begin. So I recommend you to learn it as well. Now, okay, let's begin with print hello world. That's just a simple one. You can use the Visual Studio Code. It's easy. You will figure it out yourself. How to install that. There are tons of videos out there. So we got the hello world, print hello world. That's how it looks like. You can write that yourself. And yep, so that's the first ever code we write as a programmer. And we get the additions, right? We get the subtraction. That's how it looks like, as easy as it is, as it looks, right? So it's obviously not going to be like this. It's not going to be looking like this. Something like this, right? It won't be looking something like this. As you can see, it works. It works because you can make it work. Let me show you how. Well, print wasn't a good one. Changed places, sorry. Okay, I think now that makes sense, and it will be 2. Okay, so it's clear, right? You can also make it this way, but I make it a little bit complex. For now, we can stick on this one. So we have 1 plus 2, 1 plus 1 is 2. The subtraction will be equal to 0, exactly. Okay, so we have multiplication. Multiplication will be equal to 1. Yep. And we get the, again, addition. I don't know why there are 2 additions, but alright. We got the subtraction again. We got the multiplication, right? So we get the multiplication here. And yeah, it's the same. We got the division. Now here comes a little bit challenging part, but I wouldn't say so. Let me show you. Okay, so we've got the division. We know that 1 divided by 1 equal to 1, right? And that's just an answer. When we divide 1 to 1, it's 1. But how about the 2 divided by, let's say, 3. How's it gonna look like? It's gonna look like that, right? And that's the answer we get. This is an answer we get. Now here's another thing we gotta be looking at is exponential. So exponential, as the name suggests, this is an expression, right? We know that 2 multiplied by 2 is 4, and 4 multiplied by 2 is 8, so it will be equal to 8. Clear. Now we got the division and we got the modulus. What does the modulus mean? Modulus is a answer that comes like that. I will show that. I'll demonstrate that. Okay, we got the 2 divided by 1, right? And it will be 0. Isn't it 2? No, it's not 2. Why is it? Well, because when you divide it, right? When you divide 2 to 1, you give 2, and it will be 2 and it will be 0. So this is what we're talking about. This is modulus. This is modulus, okay? That's the modulus. So you have to remember this alongside with division, because that's very important. You do not want to confuse this one with this one, okay? So we have, let's say, 4 divided by, let's say, 3, right? And we know that this is 1. We give 1. It will be 3, 1, right? And we have this one. We have 0 again. We have 3, 9, 1, 0, 3, 9. So it goes along the way, right? How about that? How about what's the modulus of 4 divided by 3? Let's see. So we are dividing 4 by 3. We get what? We get 1. You know why? Because we don't need this part. Like, we get just 1, and that's all. Like, you can cut it off, you know? You can cut the rest. It goes to infinity, right? So we get the least, how to say, reasonable number, right? We can have like big numbers too, like 43 divided by 3, and then like goes like this, you know, 3, you know. So we don't care when it's modulus. We do not care about this part. We care about the modulus, okay? It may be like 3 or 4 or 5 numbers in modulus, but we know that this is the least reasonable number we can have in modulus, okay? All right, so clear. And we have floor division operator. Now floor division is the same as division, but it's like floor division. Like, okay, we can have what? We can have this one. We know that it's 2, right? Yeah, sure, it's 2. How about 5 divided by 2? It's gonna be 2.5, right? Nope, it's 2 because it's 4 division. It kind of like forces it down, right? To the least reasonable number, to the least reasonable integer. Even if it's like 2.9, right? Or 3.5, it will make it 3, that's all, right? Even if we have like, let's say we have, let's say like we have like this much of a numbers on our hand, right? And so when we draw this by this full stop, we get rid of this part, right? So this is floor division. This is what it shows on the output. Okay, so that's the thing. And we got the types, data types. We got the integer, right? So what is integer? Integer is this one. Okay, let me show you. X equal to to, let's say, 1. Okay, so this is integer. X equal to 1 is integer. And let's print it. This is integer. All right, this is an integer. Now we have float. Okay, float is this one. So simple. Type, we have complexes too, but that's like a linear algebra thing. We'll go into it too. And we have string. If we change it to the wording, right? If we change it to the wording, let's say project V. So this is a string, right? This is a string, and we can print it, but we want to know the type. What's the type? The type is integer. Oh, sorry. Type is string. Okay, we got it. Class string. So it shows that it's string. We have list. You have to remember the difference between tuples, dictionaries, and lists. I give the same advice to myself, so you gotta do that too. So we have list and we have dictionary. We'll be going into dictionary, but please remember that dictionary includes key and a value. Okay, you need a key to access the value. We have key to access the value. Again, key, access the value. And we have list. If you, the easiest way to remember the list is, okay, let's imagine these two brackets, okay, and it includes several things in it, right? So you can imagine that brackets as paper, right? As paper, and paper, it has a couple of things going on in there, right? So that's a paper, and it has a list. So it's a list. Now this is a list, and we have what? We have dictionaries. Again, dictionaries are this, and it has key and a value. We highlight the key and we highlight the value. Okay? We got key and a value. All right, so this is dictionary. How about tuples? Tuples are the same. So let me show you, let me demonstrate that quickly, so it becomes much more clear to you. Okay, we have three types. We have lists. We have dictionaries, and we have tuples. Tuples seems to be random. Well, that's what I assume. Okay, which is what it is, but we'll, face that later. Anyways, we got the lists. The easiest way to remember it is this. Okay, you got this expression for the list. This is what it looks like. All right, I'll make it bigger. This is a list, and you write something inside it, like okay, that's the list. Easiest way to remember. Now we have what? We have dictionaries. Oops. Okay. Oh, okay. Then we'll make it bigger. We have dictionaries. Dictionaries, expression for dictionary is this. This is dictionary. Okay? This is dictionary. Because you know that dictionaries are now in the past, and in the past they used to have this they used to have this, like this. Uh, Imagine the Declaration of Independence paper, and it have like this kind of like medieval style writing. So we no longer use dictionary papers, but if we were, that's how oldish it looks. So you can get these brackets, this expression, as something old. So when you remember something old, it's dictionary. We don't use physical dictionaries anymore. So this is how you can somehow understand S, right? And a dictionary also, dictionary has this, okay, all right. Now dictionary has what? Has a key and a value, okay? We have key, okay, which already in a dictionary, all right, it's already in there. And we have value, okay? So to access the value, to access the something valuable, to access money, okay, money, you gotta have a key, all right? Safe, okay? So it's locked, okay? So you gotta have key to unlock the money. So that's somehow the easier way. We get the tuples. Now tuples are the combination of lists and dictionaries. We know that list included these expressions, right? List had these expressions like or like this: word, sentence, animal, whatever. So this was a list. Now the dictionary was what? Right? This is for demonstration purposes. That's the list. Now this is value. Okay? Now we get the both of their combinations here. We get the dictionary's expressions, okay? And we get the logic of lists for tuples. Okay? Clear? Again, I repeat that once more. We get the expressions for tuples. We get what? For tuples, we get the expressions. We get the expressions, right? And we get the logic of lists. Lists logic. So tuple is a child of lists and dictionary. This is a dad, this is a mother, and this is a child. That's the easier way to remember it. In terms of like of its usage, right? Okay, clear. So yeah. Now the reason I'm explaining that slow and for so long is because you want to remember the concept, not like look at it every time. So the best way to remember it is by having those examples, and so you never look at this part ever again, right? Okay, we are done with day one introduction part for Python, and we get to have the what? We get to have the day two. Here we go. Now we're moving to day two. Now day two is a little bit complex, yet easy. Let's go. Okay, built-in functions. In Python, we have lots of built-in functions. Built-in functions are globally available for your use. That means you can make use of the built-in functions without importing or config. Some of the most commonly used Python built-in functions are following: print, right? So built-in means like it's built within a Python. Like it's not something that you can import, right? It's not something outside, it's something already exists, right? That you can make a use of it. So we have point, we have print, we have length, we have type as we have seen previously, we have integer, we have float, we have string, input, lists, dictionary, right? We have dictionary, we have list, we have dictionary, we have minimum, maximum, sum, sorted, right? I would like to test this maximum just for demonstration purposes. Let's see this maximum. Okay, let's say that you want to print it immediately and you want to have this maximum too. 3, 4, 5, 6, 99, 89, 100, 22. I think it will just print 100. Yep. So this is built-in function. So that's the whole purpose of functions. Okay, so we'll see an exhaustive list of Python built-in functions taken from documentation. This is the source, you can refer to that. We have all these functions. You don't necessarily like have to remember all of those functions, but it will help you a lot, right? The more we use it in our projects, the more we remember. Just like the language you learn, let us use Python, shell, and start using some of the most common built-in functions. Now, the author of this repo repository, he's using shell, but we can use Visual Studio Code. That's what I use, and that's pretty convenient for me. Okay, so the author is using string. It converts number to string. So here's the thing. Can a number be a string? Yes. So can a number be an integer? It's already integer, but you have to define that it's an integer. Right? Can a number be a float? Sure. We do not say like 10.0, we just say 10, but 10.0 is also correct, right? So input, we have this beautiful, great, we have this beautiful function called input. Can we find it here? Can you find it here? Where is it? Yes, input. So what is input? Input is a user interface, basically speaking. That's like a front end of everything that is gonna happen within the code. Okay, so we have input. Okay, how old are you? How old are you? We will put a variable age, right? And print, we will print age, right? So when the user types anything to the question how old are you, right? To the question how old are you, it will print the age. Okay, how old are you? Okay, 14. That's all. It's just asking a question. We can like add number, okay, but we have to define that it's an integer. We have to define it. Okay, it's an integer, and we now have age plus, let's say we're adding 30 years to it. Okay, and then we're calling it out like, oh, you are so old. right? So, okay. And the user goes like, oh, wait a second, I'm not that old. The computer is, the computer is wrong, you know? Okay. I'm 20 years old. Oh, you're so old. No, I didn't say I'm 50. I said 20, right? So something like that. Okay. We have this. We have, let's use practice more by using different built-in functions. Okay, let's see. Okay, we have this. You can ask help from Python. So it's like built-in function, literally. Okay, so when you type help, copyright. Oh, wait a second. Okay, when you type help keywords, it will give you all the keywords like false, none, true, and, as, assert, class, continue, def, del, elif, else. So it's like a cheat sheet in the exam when you need a little help, when need the help with the remembers of the keywords or variables or functions. You can just literally use it. You can just say help and ask something. That's literally possible. So as you can see from the terminal above, Python has got reserved words, right? We do not use reserved words to declare variables for functions. We will cover variables in the next section. Yeah, we'll be looking at the variables. I believe by now you're familiar with built-in functions. Yes, we are somehow familiar. We don't have to remember all of the things, but you got it. Let's do one more practice of built-in functions, and we'll move on to the next section. Okay, so this is a practice. We already seen it. As you can see, it has like 20, 30, 40, 50. Of course, it's gonna take 20. 20, 30, 40, 50. Of course, it's gonna take 50. Right? So we have the same, we can do the same expression for lists, I believe. It takes list as an argument and return minimum, right? It takes list as an argument and return max. So we can literally take the big numbers from the basic code, as you can see, but also we can take it from the lists. It's possible, right? Okay, so you know that you do not define the list, right? You don't type like list. The basic definition of list is this. Okay, so that's the list. And this is a dictionary. Okay. All right, and we have sum. Sum, again, it takes on list as an argument and return the sum. So it kind of like sums it all up, right? Okay. All right, so variables store data in a computer memory. Let me do one more quick example. Let's define the age gap between your parents, between your dad and you, okay? Now, I'm gonna call the first variable dad. It's gonna be an integer number because, the user is going to input an integer number. And we have input, right? And we have how old is your dad? We're gonna use the max expression. Oh, sorry, sum expression. You'll see. And you, right? Integer input. How old is you? I mean, it's gonna be how old are you, but in the hood, they say, how old is you? What's up with you, Okay, so that's like a hood's language. How old is you? What's up with you? Okay, and we have like adding. I'm just gonna call it adding. Okay, we have sum. Okay, sum of what? Sum of dad plus, oh, sum of dad and you. Okay, sum of dad and you, and then extract. We call it extract. Okay, we have adding minus minus u, right? And we're gonna print extract. Okay, I hope it works. How old is your dad? Okay, 42. How old is you? 20. My apologies. My sincere apologies. Let's see the mistake. Let's see what didn't work. Okay. Okay, so the type error int object is not iterable. Okay. What could be wrong? My dad is 40 and I'm 20. And so we are extracting. Oh, okay. I'm sorry. Now we got to solve it, because you see, adding is a string because we did not define it, right? Now, when the sum comes to be, let's say 40 plus 60, 40 plus 20 is 60, 20 minus 40, 40 minus 20 is 20, whatever. 60 minus 20 is 40, whatever it is. So we define the integer. Let's see now. How old is your dad? My dad, I'm not gonna write my dad and stuff like that because it's gonna give me error. So that's like a trial and error thing. We will take a look at it too. But how old is your dad? My dad is 42 years old. How old is you? I'm 20. Wow. Okay. All right. Come on, chill, guys. I'm just trying to use that and you. What could be wrong? What did we wrong ourselves in? Oh. Okay, let's see now. This is gonna be an integer, I think. Okay, let's see. How old is your dad? 42. How old is you? 20. Object is not iterable. Oh, in sum, like you gotta use numbers. You gotta use integers. You cannot use words, I think. That's why. I see. Okay. Well, then to resolve the issue, right? Well, we are not gonna use sum. We are just going to add it. Now it will be clear. Okay, how old is your dad? 42. How old is you? 20. 42. Oops, what happened? Okay. What's the age gap? Well, I think I'm failing on basic math. It's not that I don't know, but it's that I'm seeing it as something very easy and I'm just ignoring the simple things in my mind. Okay, you can see how dumb I am sometimes. Okay, so to define the age gap between my dad and me, first thing is we have to know my dad's age. My dad's age is 42, let's say. My age is 20. Okay. Now to define the age gap, we have to just subtract it. 42 subtracted by 20. The age gap is 22. As simple as that. And I was like overcomplicating things, you know? I just want to use some, and I think I made things a little bit hard. But one thing you can take from this stupid example I have given you right now by trying to use this sum function, by trying to making use of some function, is that how the programmers think. Like, to be able to come up with some code, you gotta have something in your mind, right? So when we are doing some projects, if you cannot imagine that logic inside that, mind of yours, like if you don't have this logic, then you will definitely stumble upon these stupid issues. Like look at this. What did I do, As so I believe that's understandable enough for now. So to fix this issue, we're not gonna use some. We're not gonna do some like issues like that. What we're gonna do is like just extract, right? Okay, just gonna call it extract. I'm just gonna subtract my dad's age from my age, right? So the age gap is gonna be clear. Okay, as simple as that. How old is your dad? 42. How old is you? 20. So the age gap is 20, right? Okay. We can write, there's this function. Okay. All right. Just a second. Okay, what am I even doing? Just forget. Okay, there are two ways. Extract. Okay. So the age gap is, and then like this one. Okay. All right. 60 and you're 30. So age gap is 30. Okay. That's how it looks like. Again, in order to write the code, you know how to write the code. You know the functions, you know everything. But if you don't have this common sense of logic, not the common sense, but just the logic inside that you're thinking of, you cannot build something. You gotta have this idea in your mind, a vision to make it happen. Okay, so I believe that I did not confuse you somehow. I believe that you learned from my mistakes, and you probably called me stupid at some point, but that's fine. Variables store data in a computer memory. Mnemonic variables are recommended to use in many programming languages. Mnemonic variable is variable name that can easily remembered and associated. Okay? A variable refers to a memory address in which data is stored. Number at the beginning, special character, hyphen are not allowed when naming a variable. A variable can have short name X, Y, Z, but more descriptive name, first name, last name, age, country is highly recommended. If you have seen to my code, if you have taken a look at my code, I have called dad because I'm asking question about your dad, right? Because you want to access, this code can be much more complexer than this 6-line code. It can be like 30, 40 or 100 lines of code in here. right? With if and else cases, but please don't go further for now. Anyways, this code can be bigger, right? And to be able to like navigate through code, you gotta have this variable name. You see, if you point it out, it's called variable. All right, it says it's variable, and this is function. You see that? You see that? This is function. That's how it is. Okay. All right. Clear? Clear. I hope it is. So when you're asking your mom question, you just gonna name it mom. As simple as that. No need for complication. When you're asking for the first name, you just name it first name. You're not gonna say your first name. Or if you're writing a code to the Queen of England, rest in peace, you are not gonna write first name of your highness. You're just gonna point it out first name. The Queen of England is not going to take a look into code and tell you, oh, you did not honor me. No, that's not how it's gonna happen. You just gonna write the code. All right, not to waste time. Now, invalid variable names. Invalids are this, okay? You cannot have a variable name like this. Like that's literally wrong, okay? Even if you were to do this like this, that's literally wrong. So the basic one, easier one is like this. Right? It's gonna work, you will see. Like this. You can make it happen. Okay, so there are different cases, and I think you don't have to like look at all of them. It's like a trial and error thing. You have like oh, too much. The age gap is 42. That's all. Okay. We'll use standard Python variable naming style, which has been adopted by many Python developers. Python developers use snake case variable naming convention. Okay. Yeah, so this is called snake case, right? Snake case. Those are not snake cases. Snake case. Okay. Think clear. Yeah. So here as you can see, what it is? Exactly. This is dictionary. What is it? This is list, right? And what if it was this one? No, wait, this one and this one, tuple. Yeah. Okay. All right. So let us use print and len built-in function, right? Print function takes unlimited number of arguments. Example, hello world. The text hello world is argument. Okay. Hello world. It takes multiple arguments for arguments have been passed. Hello world takes only one argument. Yeah, so what is it saying is that like we have this argument. Let me show you. Okay, so we have this print hello world. Print hello world. This is one argument, okay? Hello world, hello James. This is second argument. Okay, after that you have to put this, what is this called? I forgot. What is this called? Wait a second. Oh, come on. Okay. Okay. What is this even called? Okay. What is it called? Oops. What is this? Come on. You know what? You gotta be kidding me. You got to be literally kidding me. Okay. 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 Oh my. You gotta be kidding me, man. Okay, you know what? Forget it. Whatever it's called, I forgot its name for now. Just keep it. Okay. All right. Let's just ask GPT. What is it called? Comma. Oh my god. Okay. Anyways, we got the declaring multiple variable in lines. So we can declare multiple variables. So if we like, it's like this. Okay, let me show you. Did I explain? Okay. It's so similar to REST APIs. Also, Java also have it. I was just looking at it. Okay, let me explain that to you. Okay, we have this what? We have this one. Make it bigger. Okay, so first name. Oops, what is this? You know what? First name is Asabi. Last name is Yatai. Country is Helsinki. Age is 250. Wow. Married, true. Okay. So all of them are equal to each other by comma. So this comma is something that bounds them, right? So we have first comma for the first answer, second comma for the second answer. And so you can make it as input and output. Okay? Let me like demonstrate that to you from these examples. Not to waste the time, I'll just take this one. I'll just copy it and show it to you. Okay, we have those, right? So we have to print them. But, okay, you know what? That's how it looks like. First name is input first name. And that's why we can like website scraping, like those informations, those variables that is like constantly updated in the background. We can give those variables to AI. So based on that, it will do some calculations, right? Okay, if we have input first name, you got to be, what The heck is my... Literally, what is it? Okay, finally. Hopefully it's gonna work. Okay, it's working now. Input first name. Okay, we have age, input, okay, input your age. Okay, so now based on that, we can also, I think, print both of them. Print age, first name. Okay. Whatever, I mean, the first name is Sean. Input age, 23 Sean. So you got it. You got it. So those are data. That's how websites, that's how internet extracts data from you. Okay? And they keep it in their database. And they use those databases to train AI. Such a good job. All right. So we have getting user input using input. Yeah, we saw that many times, right? That's what we literally did. Come on, that's what I literally did now. Okay, so data types. We have data types, which is string, integer. It's not my real age, don't worry about. Okay, so this is when you're asking for a number, whatever the number it is, right? It's gonna be an integer, all right? Checking data types and casting. Check data types. Certain data variable, we use type example. Well, we saw that previously, right? We saw that this is string. Just try not to look at this side. Just say that yourself. Like, try to say it yourself. Okay? Let me like remove this part and say it together. How about that? Okay. Boom, boom, boom. Boom, boom. Okay, so this is string, this is string, this is integer, this is float, this is complex, this is boolean, this is list, this is dictionary, this is what is it? This is integer. Oh wait, no, that's string, yeah, that's string. And this is, what is it? Well, okay, this is zip. Never heard of zip. Oh, this is not zip. Oh, this is tuple. The heck? I thought the tuples look a little bit different, no? I mean, come on, like I literally just explained it there. Tuple looks like this. It has this expression. 2. Oh wait, was the example wrong? Did we get it wrong, or what? Where did we see it? Forgot. Did we saw that in here? Yeah, so that's the tuple. Why you lie? The tuple used to look like that. Okay, you know what? We'll figure it out. No worries. Anyways, we got the last one. At least we know till the dictionary. And tuple is a little bit confusing. And zip, never heard of that. Castic, converting one data type to another data type. We use integer, float, string, list. Oh yeah, we can convert certain data types to different data types, right? So, okay. We'll talk about concentration string section, okay. All right. So, we have number, integer, okay, so we literally can like convert integer to float. It's possible. We can make it float to integer. If this is like 9.81, we can make it integer. Like literally. Take a look at it. Print what? 9.88. But unfortunately this is float now, right? We say nope, this is float. We say nope, this is float. Oh, integer, sorry. Yeah, you see? Okay, we have integer to string, possible string to integer or float, possible, we have string to list. We have this, if we have this string and we just do list, we can get each letter from here as a list. Okay, this is something to remember. Can I like highlight it? No, not possible. Okay. Anyways, hope it's clear. We got the numbers, number data types in Python. Okay, we have integer. Okay, negative, 0 and positive numbers. They're integer. So if we have like negative or positive numbers, whatever the number is, it's integer. Floating points, the same. Complex numbers, the same. Thank you. Exercise level 1. Okay, folder called day 2. Okay, it's just saying how to do this, do that. We already done this. You can do those exercises yourself too. Check the data type. Let's take a look at the code. So we have first name variables, right? We have string, integer, boolean, right? Boolean, list, dictionary, right? Correct. Now print the values stored in a variable. Printing the values, yeah. If you have like variables stored in the like on the data, like on the background, you can literally like, you know, how to say, print it. Let's see. Okay, let's see it through a very simple example. You can take it, you can copy paste. So this is those are variables assigned already, right? And we're gonna print them. You see, you can change the variables in here. If you're lying, you will say you will remove HTML, you will remove CSS, you will just remain JavaScript, React, and Python, right? in the personal info, it's for JavaScript. Like I've seen these things like type of remainders in JavaScript, but you don't have to pay attention to person info for now. Just this enough. Okay. First name, last name, country, city. You can change that if you want. Oh, wait a second. Oh, last name length. First name length. Okay. Alright, so that's how it's operated in databases. Okay. Alright. I explained this one. And we have this. Right, the same thing. Print country, age is married. Alright, we are done with day 2. Let's take a look at day 3. I think we'll go as far as day 4 today, I believe. Right, if you want to take a rest, please do, because I'll come back and we'll be get going from here. It will be just one long video, I guess. So we have the day 3. So the reason I'm speeding up the process, because those are just the basic things, and if you don't understand the basic ones, that's absolutely fine, because along the way as we do the projects, you will be able to understand it. So we have booleans. That in the third day we will be looking into operators. What are the operators, right? So operators are, one of the operators are like, equal and all of this. So we'll just take a look at it. Anyways, we have booleans. Booleans are true, false, and false, true. Anyways, let me actually, how to say, show you how does the boolean work. Okay, we have boolean. Okay, and that's like an introduction to information technologies, right? If we have like true and false, like true and false gives us what? We'll take a look at it. I just forgot. I have to like remind myself. Boolean true false table. Right? So okay, here it is. If we have false and false and false, it's gonna be false. False and true is false. True and false is false. True is true and true. It doesn't make sense. That's absolutely fine, because that's we will be maybe look deeper into it when we play the game called on the Steam, in Steam, called the there is this famous guy, I remember, Turing machine, that invented this Turing machine. So Turing Complete. Yeah, I just remembered the name. So there is this game called Turing Complete, and when we play this game, we'll probably use this kind of logic. False, false is false. False, false is false. False, all false. So, anyways, what you have to understand is for and, as you can see the pattern. Let me actually copy that. Okay, so those was from the previous. Anyways, I got this right. Oops. Anyways, I think it's visible enough. I believe it's visible. I'm so sorry for what happened right now, but okay. So we have you have to remember that in and right, in AND, if one of them turns out to be false, it will always give false. If one of them turn out to be true, true and false will give us true. Because true or false is true. Because it can be false, but it also can be true. That's why we choose true for or, in case when true and false comes together. Right, so we have true and true is gonna be true for both and or, and true and false is true, false and true is true, false and false is obviously false for both of them, just like true for both of them. And not true is, again, if not true, then it's false. If not false, then it's true. As easy as that. So the logic goes like that for Boolean. Now we have operators, assignment operators. Assignment operators are used in assign values to variables. Let us take as an example, equal sign in mathematics shows that two values are equal. However, in Python, it means we are strong. It means that we are storing a value in a certain variable. We call it assignment or assigning value to a variable. Okay, so we are assigning a value, right, to a variable. So this is an example. This is value, right? This is value, sorry. No, this is value, and it is assigned to a variable 5. Okay? Now, you have to remember this short form because that's very, 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 very much important. That's just the short form of this. Okay? All right. Here's an example. All right. Anyways, x equal 5. We know that x equals 5. Now we want to, like, how to say, get this x to be added, right? Like, you know that in Python, it goes order by order, like 2, 3, 4, 5, 6, 7, right? So it goes by order, all right? So it goes by order, and it's very important. Like, we know that previous x is not gonna be equal to the current x, because the current one is the latest one. The latest update we have is the last x. Okay, so let's print x. What do you think? Which one is gonna pop up? What do you think? Which one? Is the first one or the second one? Second one, you see? So even if you have a like hundreds of those, right? Go like that, like that, like that, like that, like that, like that, okay? And then in the end, you have like x equal 100. Sorry, those are just minor mistakes. I will just, let's just imagine. Okay, so we have this, and print, it's gonna print 100, not the one previous axis, okay? So we can, by using this exact logic, we can use this expression, okay? Let's see now. Let's see. Okay, we know that x equals to 1. We don't have to like define x1, x2 or anything. But you can do that too, but anyways, it's that simple. X equal to 1, and the new x equal to x plus, let's say, 5, right? So when we print x, we end up with what? With 6. Exactly. That's how it looks like. Okay, so yeah, that's how it looks like, and that's how it is. And the short expression for this is going to be like that, okay? As simple as that. It's gonna give us 6 again. Remember, this one comes first, and equal sign comes second. Okay, so the operators comes first, right? The operator comes first and equal sign comes second. I mean, this one itself is an operator already, but just for demonstration purposes, I want to tell you that whatever expressions you have, it always comes first. Just remember. Okay, so you have a purpose, all right? You have a sense of purpose in life, and so you make it equal to something to achieve a goal. Okay, so you can interpret it this way. If you don't have a purpose, then it's just equal to your goal, equal to what you're looking for. If you don't have a purpose, but if you do have a purpose, you define your purpose first, then achieve your goal, right? Just like that. The purpose is to add, right? There is no purpose because already it's equal. It will never change. But here, there is a purpose. There is a purpose and it equals to something and it will give you a result. Okay? So the same for division, for multiplication, for subtraction, multiplication, division, modulo. You remember modulo? For floor division, for what was that called? Whatever it is, you got it. Okay, so yeah, that's how it is. I don't know what is this. I don't know what is that, but the point is clear. All right. You have to remember this because when we start like using loops, this is where it is. It will be very important for you to make use of it. Okay, so yeah, let's see the examples. Print, addition. Okay, addition, 1 plus 2, 3. Okay, division. Yeah, it's just simple things. Print, floating point number, pi. Okay. All right, so again, it's so clear. You can see that you're printing a sentence which is like this, right? It's separate and there is comma and there is an integer. So we have string, comma, integer. String, comma, integer, right? If you want to put string here, you just use those brackets, right? It always should be separated and you make it string. Okay, not the number, but you will write something. Okay, so this is for complex numbers. Yeah. Okay, let's declare a variable. Okay, we're declaring a variable, right? The variable is a. Equal to 3. A variable name and 3 is an integer data type. Yeah, so the total is a plus b. Okay, so we are just using a and b examples for division, for modulo, for remainder, right? It's called modulo for remainder. So what do you think? 3, like modulo 3, modulo 2, it's gonna give us 1.5, right? In terms of like if we divide it. But what's the remainder? The remainder is 1. Okay, the remainder is 1 for 3 modulo 2. This is remainder is gonna be, I mean the floor division is gonna be 1 also. Yeah, exponential, it's gonna be what? It's gonna be 9. Yeah, so yeah, that's how it looks like. Examples, we have addition, subtraction, multiplication, division, modulus, total, different. What is it giving us? Product, number 1, number 2. Okay, example, another example. Let us start connecting the dots and start making use of what we already know to calculate area, volume, density, weight, parameters, distant force. Okay, now that's where we start to use the knowledge we have into the real world. Okay, that's why I had, if you previously remember, I had mass expressions. That's why I hate them. Okay, so we're gonna make some sense out of it, right? We're gonna use some mass expressions to come up with an answer. Okay. All right. So we have radius. Calculate area of circle. We have radius 10. Area of circle standard multiplied by this, which is the, what was that? What was that? Exponential was 2. And so it's just formula. We calculate the formula. We found the area of circle, right? We got the formula and we make it into code, and you can make a program out of it, literally. Okay, calculate area of rectangle. We have length, width. Again, if you know the formula, you can put it away. Right, so here's the thing. Here's another thing. So you gotta know the formula. If you don't know the formula, again, to be able to create something, like to be able to create something, you gotta know the formula, right? You have like formula in your mind, and so you have this, okay, plus, like you have it. So you know the formula, and you know the Python language, okay? You know the Python, and both of them will equal to your creation of a program. Now that's the simple demonstration of basically making things happen. Now, what's happening with the vibe coding and what's happening with all of this hyped up things you see on the media on everyday basis is here's what's happening. Okay, here's you. Okay, you have an idea, but the idea itself is already abstract in you. Like, it's not like exact formula, which is okay. And here's the thing, you have been like perceived by those gurus out there that you can make things happen and you can earn like hundreds and thousands of dollars with this idea you have. They are pointing out to this freaking idea you have, right? They're pointing out to this idea instead of like having to teach you some technical knowledge about making this idea happen, right? You don't have any technical knowledge. So what happens is you are like perceived by these gurus' ideas, and you go into tech and you learn it and you burn out along the way. You burn out along the way, and you go to the gurus again. They ask you more money, and you go back again to the technical things yourself, and you go a long way and you burn out again, and so you're stuck in this cycle because you see, if you didn't have Python knowledge, you would just know that for yourself, right? And you would ask someone to make it happen for you, right? Instead, you don't have any technical background. You're running into those gurus out there who's claiming to have a course that will make you a genius, but it turns out that that's not how it works. How it works is you gotta have some technical background of yourself, right? You gotta have some technical knowledge, at least, like, as long as you're confident about making this idea happen, right? So let's start from clear approach. So you gotta have some technical background, technical, at least, like, knowledge. You will not go to these gurus out there. Going to the guru is the worst thing that you can do. They're money making machines for themselves, not for you. Okay, so you go to the technical background, whatever people say, whatever the hype is going on in your mind, whatever people is saying, that's a fucking slow way of doing it. Sorry for swearing. That's very slow way of learning. You will never go far, and all of these gurus just play with your emotions, right? You have like emotions on the side as well. So you have emotions as well. So they play with your emotions. They're connected to your emotions, which is connected to you. So you gotta cut this off. Not the emotions. Emotions are natural, but this side of the gurus, right? You don't want to pollute your mind. So you want to learn technical background. You want to have your idea and make it happen. And once it didn't work, then you can go to those gurus to make it happen. And the time you go to those gurus is actually the time where you figure out that whether they're scammers or they are just playing a survival game where they teach you something and literally earn a a faithful money, right? So that's the thing. So please, I have faced that myself. I have wasted a lot of money for those gurus. So please don't. Have to have some learning. Have to have some like technical background of yourself. Learn something um, without resisting it. The real knowledge, right, available out there, instead of being stuck in this forever cycle. You're stuck in here like a hamster. So I will keep reminding myself this, and I will probably cut it off and put it on the YouTube. But anyways, um, okay. So yeah, again, you can make it happen. You have a formula on your mind. You have, you also have a technical knowledge of variable, of everything, and so you make it happen. I don't know this formula, right? That's why I don't have to memorize this formula, right? I don't study physics. If I were to know this formula, I would definitely show it, highlight it, right? Now, we have comparison operators. Comparison is where the Boolean also comes to play. But I don't think, yeah. Here we go. True equals to true. True equals to true, false, whatever. We can like include the Boolean in here as well. Okay, we have comparison. And the comparison, it turns out to be the basis of any computing, um, any computing machine, any computing background. Like without comparison, you wouldn't be able to see computers, or you wouldn't be able to have these laptops, because the Turing machine, Turing complete, when we play this game, you will see that it all is comparison. Like true is false, false is true. It's very, very, very low. It's very low, basically, level of programming. Yeah. Okay, so that's what it is. 3 equals to. It's gonna output true and false. You will see. Let me show you. Let me demonstrate you. So we have what? We have x equal. You see, now it's equal, right? Sorry. Okay. What do we have? We have print. We have print 3 equal 4. Let's see. We have false. You see? We have 3 less than or equal to 4. True. It's true. So that's how it works. As easy as that. Yeah. Okay. All right. We got it. Now what is it? 1 is 1. 1 is 1. True. Oh, we also have is not as well. A little bit strange why the author didn't include it in here in the images, but okay. By the way, we also have is 1 is 1. True. 1 is not 2. Okay. 1 is not 1. 1 is not 2. Oh, it's just, okay. You see, it's a string and it's a expression. It's an argument. Okay. So A in SAB, true. B in SAB, false, because there is no capital letter B, right? So you see, even capital letters matter in programming, whether it's capital or small. So we have coding, coding in, coding for all. True. So we have in, is, not, all of this. Okay, so those are just minorities. You don't have to remember all of them, but just keep in mind. Okay, unlike other programming languages, Python uses keywords and not for logical operations. So you can literally make logical operators in Python. Returns true if both statements are true. So x smaller than 5 and x smaller than 10. Right? True. And or, as I have mentioned, right? I showed you the Boolean logic, right? I showed you the true-false table. Based on that table, you can make things happen. All right. Okay. So what else? What else? What else? What else? Not true is false. Not true. Okay. Exercise day 3. Okay, now it's exercise time. Write Python script that displays the following table. Okay, we can make it happen. Write the script that prompts the user to enter hours, rate per hour, calculate pay of a person. Okay. Enter hours, enter rate per hour. Your weekly earning is this much. Okay, very interesting exercise. We can make it happen. We have another exercise. Let's see. Write script prompts the user to enter number of years. Calculate the number of seconds a person can live. Assume a person can live 100 years. Enter number of years. Okay. Another very interesting exercise. Write a Python script that displays the following table. Okay, let's work on all of them. All right. Let's make it happen. Okay. The first ever exercise we'll be looking at is what? It is write a script that the user enters hours and rate per hour, calculate pay of a person. Okay, we have hours. Okay, we have hours. So weekly earnings, right? So how many hours do you work per week, right? And how much rate? What's the rate for each hour you get paid? $28 an hour. Wow, that's too much. That's too much, I think. I don't know. Let's see. Okay, so we have weekly. You see, I'm using snake logic. I think that's what it's called. Anyways, weekly hours equal to what? Integer. It's gonna be integer, and it's gonna be an input. Please enter an weekly hours. Please enter. Okay, you know what? How many hours do you work per week? Okay. So what else? How many hours do you work per week? Now we have per hour. Enter rate. Okay. Rate per, you know what? Rate hour. You can also just, make it all or just per hour rate. the same logic. I'm not gonna write it, I'm just gonna copy it here. Okay, and you can give your question here again. How much you get paid per hour, right? Okay, so that's another variable. Yep. So the third question is, okay, the third question is basically, there's no question. Now, this is where the calculation goes, right? The calculation goes this way. Your weekly earning is this much. Okay, my weekly earning is this much. So we're gonna do the calculations. So how do we calculate that? We get the weekly hour and we multiply it by what? Multiply it by, if I were to work like 1 hour per week, I will multiply this one hour by what? By rate per hour, right? That's how it works. This is where the logic is understood, right? So in order to understand some complex logic, you gotta have the same logic but make it simpler so that you understand in a smaller scale rather than in a bigger scale, right? Some questions are given in a very, very, very bigger scale, but you have to kind of like squeeze it up and output it in your mind, make sense of it first in a very small scale, right? You're not gonna think like with 100 users first. If you're like learning in the first place, you're gonna think with one user. Then when 1,000, if million of users are given to you, you will then understand the logic already so that you can just make sense of it. And when people look at you, they say, oh, you are a genius. No, I'm not. I just know the logic. And based on that, I'm just calculating. That's how it is. No one is genius in this world. Everyone is stupid. Okay? Ladies and gentlemen, that's my statement. No one is genius. Everyone is stupid. People just know the rules. Right? The rule of logic you have. If you don't have this logic, then whatever the rules you learn, it's all a nonsense, whatever you're doing. Again, the core value. You don't understand the core value, you don't understand the core logic, it's all nonsense. Okay? It's all just yapaholism, basically speaking. Okay. Alright. So calculation. You can just calculation. Okay. We calculate. Okay. We calculate. We have what? We have weekly. Okay, weekly hours. Yep. Multiplied, right? It's multiplied by what? By per hour rate. And we are going to print it. And we're gonna say print week calculator. Oops. Week calculate. Okay, that's what we got. Let's see. How many hours do you work per week? Well, I work 25 hours per week. How much do you get paid per hour? I get paid, let's say $4 per hour. So you get to earn $100 a week. As easy as that. So yeah, you can write that, right? You already have an argument. You're just gonna write the explanation. So you get paid. So your total is okay. That's where the tricky part is. because that's not tricky. That's just, yeah, that's not tricky. You will see why. What do I mean by it? Okay, your total is, we're gonna add some space in it, and then we're gonna jump off right here, right? And we're gonna have another brackets, and we're gonna say your total is dollars, right? Okay, we don't, okay, per week. Okay, there we go. So I'm working 40 hours per week. How much you get paid per hour? I get paid $2 per hour. So you earn, so your total is $80 per week. You see? All right, so we completed the the calculator, right? Let's see. Let's ask the Google about the what? How much per hour Mac? Okay. KFC worker gets paid. Whoa. Whoa. Really? Per wow. That's cool. That's cool. That's cool. Okay. All right. All right. So you can like do this calculation and okay, so typical working hours a week for KFC. Typical working hours for KFC workers. Working hours a week for KFC workers in America. 15 to 30 hours part-time crew member, 35, 48 plus hours full-time staff and managers. Okay. So for part-time, we are working how many hours? Hours per week. We are working around like let's say like on average KFC worker works 20 hours per week. Okay, 20 hours per week, and I'm getting paid how much? I'm getting paid $20. Yep. So I'm earning $240 per week. Pretty decent amount for a week. It's pretty decent for a part-time job as a student. Pretty decent, not gonna lie. For US, obviously. For countries like mine, it's it's too good to be true, you know. Okay, all right. So yeah. Well, the next exercise: write script that prompts the user enter a number of years. Calculate the number of seconds person can live. Seconds person can live. Assume a person can live 100 hours. All right, no problem. By the way, let me use the given example so that it calculates correctly, right? Yep, correcto. All right. I'm going to draft it. By the way, here's how you draft it. You just make 3 here, and you make 3 here, and it's drafted. Okay. All right. We have the second one. Enter a number of years you've lived. Okay. We have. Oh, you have lived. Whoa. I think. Oh, you have lived. Okay, still alive. I thought like that's. I thought like that person is writing. All right, so we have what? We have, okay. It will be amazing. It will be amazing to see how many seconds I have lived, you know? It will be so amazing. Okay, years. I'm gonna call it years. Okay. Or you can just call it as in snake version. Lived years. Okay. Lived years. How many years you lived? You lived. Okay. We have integer. Wait. We have input. We have integer first. Okay. How many years you lived? Basically, like how old are you? You can say, you know, but like more like a formal looking version of it. Okay, we have how many years you lived, and you're gonna there will be a calculation. Okay, so we know that all we gotta know, all right, the much easier way is 1 year equals how many seconds. 1 year equals how many seconds. Whoa. Sheesh. Okay. Okay. Alright, so we have 31,536,000 seconds. Okay, we're just gonna copy it. We can like know it from 60 seconds, but I just want to make it easier. Come on, like why make it difficult for yourself? Alright, so we're gonna do what? We're gonna do calculation. Calculate what? Calculate lived years multiplied by this much, right? And we print calculate. Alright, we print to calculate how many years you lived this much. So okay, so you lived, what is this? Okay, you know what? Let's make it 60 seconds. To be able to have the 60 seconds. Okay. Anyways, let me see. 1 minute equals 60 seconds. Right? And can we like calculate based on the 60-second logic? Can we make it happen? Let's see. Can make it happen based on that. You know? So interesting. Okay. Let's do the calculate again. Calculate. So calculate what? Calculate the 60 seconds. Okay. Bro, 20 years is too much, man. Literally. Like literally. You know what? Let me try to use it. Okay. Lived years. You know what? Like, I'm gonna see the real numbers. Assuming that I have lived 100, what's the calculation gonna be like? What's the expected numbers? You will see. You have lived this much. Okay. I have lived this much. Yeah, that's correct. I mean, that's You want to see the input? You're gonna take the. I mean, that's correct. That's absolutely correct. But I'm just overcomplicating things. Why should I think in like minutes or hours or weeks or days if I just have like, you know, this blueprint on my hand already? Okay, that's true. But why is it giving me this way? It's interesting. Or maybe it comes as a. You know what? You know what? Maybe the integer. Can I make it like this? Okay. 100. Obviously not. Why? Obviously not. Why is it giving me in this way? I'm pretty confused. Why? I mean, normally if you do it in Colab, okay. If you do it in like Colab, Google Colab. Okay, we have this one. Let's go. Just wait for some time. Okay. Let me copy the code. Oops, not this part, just this part. Okay. Let me copy the code. Let me run it. Come on, man. New code. Can you make it happen? How many years you lived? 100 years. Yeah, you see? Like, what is this? You know what? How about like getting rid of this integer? How about that? I think it's not gonna work. I'm sure about that. I'm sure it's not gonna work. It will give an error. Oh. Alright. No problem. Anyways, we got the answer. And yeah, last one left. Write Python script that displays the following table. One way we can do it is through that. That's how we can do it. Let me demonstrate that to you. Okay. We need this 3 dots. Okay. And we have this one. The most easiest way is just print it like a little. Okay. I'm just gonna make it easy for myself. Like, oops, what is this? Okay, let me just copy that print. We got this. Thank you. We got that. We got that again. We got that again. Oh, I see. Interesting, don't you think? Well, come on. You can just do this like that. So that's why vibe coding exists. Like, if you can use AI just to make this simple thing happen, you can use it. Why not? But if you don't know the concept, you just like to yap. Yeah, here's an output. If you just like to yap, then there's no way you can make it happen. If you don't understand the logic in the first place. Okay. Alright, so day 3 is over. We're gonna move on to day 4. It's time for strings. Strings is very simple one. So in day 3, we've taken a look at additions, subtractions, multiplications, divisions, modules, floating numbers. We've taken a look at the expressions, right? We've taken a look at some important concepts as well. We've touched some Boolean, right? Here's another example. Here you can see like Mango's length is how much? Like 1, 2, how many letters in it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. False. 1, 2, 3, 4, 5 is not equal. True. Bigger than. True. So you can also play with length, with the amount of letters the word includes. You can also play with it. We got the Boolean, right? And we got the true in another way comparison. Is, not, whatever, right? Anyways, that's a blueprint, right? We can have it. Okay, now let's move on to day 4. Pretty easy one, I'm gonna lie. But the easy one is, oh, yeah, there is some very important concepts. So yeah, let's take a look at the day 4 after a short break.